Hi, I'm Stryker Waddell. I'm a sophomore and majoring in electrical engineering, and I'm here interning at the National Center for Reliable Electric Power Transmission. Today, I'm demonstrating the WOW demo, or the Wonders of Wattage demo. This one is the TISA and RISA, or the Transmitting Electromagnetic Signals with Antennas and Receiving Electromagnetic Signals with Antennas. The first one I'm going to explain is TISA, the transmitting one. This one's actually plugged into the wall. It has power going in through here with a little power switch right here. The power is transferred into this antenna right here, and you can read the power through the voltmeter. This is the receiving box, or RISA. This one allows the power to be transferred from the transmitting box to this one through wireless power transfer. This one does not have any wires connected to it, and all the power that goes into it is from the transmitting box. This one has a voltmeter and a light showing whether it's connected to power, but it also has a light right here and a fan as well. The power goes in through here, and it has a little switch where you can transfer the power from the light to the fan. This allows you to show that the light is dimming or gets brighter depending on how much power is being received, and also the fan, which slows down or speeds up depending on how much power is being received. You might be wondering how this works. Both of these have copper coils on the ends. The power goes in here through the circuitry, and then the current goes up and around the copper coil. This creates a magnetic field. According to the right-hand rule, which is a great way to visualize this, whichever way the current is flowing, in this case, this way, you can wrap your hands around in that way, and it shows the magnetic field in the direction it goes. Whereas, in the opposite direction in which it goes this way, you can put your hand, represent where the current is flowing, and it shows where the magnetic field is going to be created in this direction. So, for the receiving box, when we move the transmitting box pointing towards and the copper coils are facing each other, as you know, the magnetic field from the transmitting box is pointing this way. As the magnetic field hits the copper coil in reverse order, as the magnetic field points this way, you know that the current is flowing this way. So as the magnetic field hits this, the current is flowing in this direction, which then powers the circuitry, which powers the light and the fan and the voltmeter, all through the magnetic field that is being passed through the transmitting box. Now that we know how the machines work, we can plug it in and turn the power on. As you can see, the light is being turned on the receiving box from the power in the transmitting box. So, to create an experiment to see how different materials affect the magnetic field between the two coils, we have two different materials here. We have paper and metal. We're going to put these in between the coils to see which one will disrupt the magnetic field between them. So, let's form a hypothesis to decide which one will be most disruptive. Which of these materials do you think will disrupt the magnetic field the most? Now, let's test our hypothesis to see which material will disrupt the magnetic field. As we can see, the receiving box has a light right here. If the light shuts off, that means the magnetic field is being disrupted. So, first, let's put the paper between the two coils to see how it disrupts the magnetic field. As you can see, the light was not affected, meaning that the magnetic field was properly passing from one coil to the other. Now, let's put the metal between the two. As you can see, it shuts off completely when I put the metal all the way through, meaning that the metal is completely disrupting the magnetic field. Most people would assume that because metal is a conductive material, it would allow a magnetic field to pass right through it. However, the opposite is true. Because it is a conductive material, that means that the magnetic field is being absorbed by the metal, allowing it to not pass from the transmitting box to the receiving box. These are concepts that are commonly found today in things like wireless phone charging and other devices that show wireless power transfer. Thank you for watching, and I hope you learned something today. Like and subscribe.